The third method that we will mention is ECLAT, frequent pattern mining with vertical data format. The idea is to use set operation to find frequent items. Still, it's growing from the shortest pattern to longer patterns. ECLAT stands for Equivalent Class Transformation. So a transaction database is typically look like this, right? We are familiar with this, but we can actually convert it to an inverted index format, where we can actually put items as the key and put item transaction list. This is TID list is transaction ID list. So here 10 and 20 indicates that the item A occurred in transaction 10 and 20. Okay, 10 and 20. So use this inverted index format. There's a couple of advantages. One, we don't need to count. The item set count can be easily generated by looking at the length of this vector, right? So the idea, again, it's deriving frequent item set from short to long, recursively adding items, merging frequent item sets. And this is also more efficient than a priori. And we can see from FP growth and ECLAT examples, we can see that using appropriate data structure can help with the algorithm efficiency. In FP growth, we used FP tree that records all the count information in the tree. So we don't actually have to redundantly store all the items separately. We can aggregate them and get the count. And we can efficiently partition a whole FP growth tree into smaller trees, subtrees that can be parallelly processed. In here, the ECLAT, we used vertical data format that again can help us remove the bottleneck of counting. So using one example, this is our inverted index data structure. We have items and the transaction IDs where this item appeared. And then we can, to find from the one item set to find the two item sets. Remind you, our minimum support in this case is 2 now. We can just do a set intersection. We intersect 1 and 2 and find the common transactions. And we can, by looking at the transaction length of the TID list, we know that those are not frequent. We remove those and we do the, when we can merge them again or do intersections among those frequent 2 item set to find 3 item sets. The drawback of this method is when you have, if this item being purchased 10,000 times, you will have really long TID list, and finding intersections among those very long sets can take time. So that's the intuition and the basic difference of ECLAT with a priori. Next, I want to quickly mention mining close frequent patterns and the max patterns. We actually have already mentioned it before. The idea, so one of the algorithm, closet plus is a method that mine directly close the pattern set. So we don't actually need to generate frequent items and then filter out non-closed items. We actually directly mine closed item set. The intuition is, as I mentioned earlier, the system will have a set of the initial candidates, and those are all considered closed, starting from one item set. and then it continue adds item to it. If the system finds X is a superset of already found closed set with the same support, then the system knows X is a better candidate for a closed set. The smaller set that already existed closed set is no longer should no longer be considered as a candidate. So this new superset becomes a new candidate for a closed set. If the system finds that F is a subset of already found closed set, then we know X is not a closed set. If X is a subset of already found closed set with the same support, then X cannot be a closed set. That already found closed set should maintain its candidacy as a closed item set. So in FP growth, the book discussed some of the techniques. I don't think we need to get into too much details of those, but the idea is just be aware that efficient algorithm that directly mines closed item set exist. Okay, so I should actually conclude this short video.